We are studying the second chapter, Numbers and Sequences. Today's topic is Geometric Progression. The exercise is 2.7. Let's go to the definition. A geometric progression is a sequence in which each term is obtained by multiplying a fixed non-zero number to the preceding term except the first term. The fixed number is called the common ratio, and the common ratio is usually denoted by R. So here this is an example of a geometric progression, or GP as it is called in short form. This is a GP. So first term is A, and then we are going to take a number R, okay, that it is a fixed non-zero number. This R cannot be zero, okay. It's a fixed number. This R I'm going to multiply to the first term and get the next term. Okay, now for the next term, again I'm going to multiply this with R. I will get AR square, so forth. So this is a geometric progression. Okay, this fixed number which we are multiplying for every term, that is called the common ratio R. So here we can see that the second term, if we divide by first term, AR divided by R, A will give us R, common ratio. Similarly, the third term, if we divide by second term, you will get the common ratio R. So any term, if we divide with the preceding term, you will get the common ratio. Okay. So the general term Tn, we learnt for arithmetic progression. So here let us find out what is the formula for the nth term of an geometric progression. So it is also denoted by Tn. Tn is equal to A into R raised to n minus 1. A is the first term and R is the common ratio. Okay, let's do sums from the exercise. It will become very clear. Okay, question 1. Which of the following sequences are in GP? So let's take the first sum. We have to check if this is a GP or not. For that, the simple method is divide the second term by the first term. Let us see what you get. So T2 upon T1. Second term divide by first term. This is second term, this is first term. 9 upon 3. You get 3. Similarly, do the third term divide by second term. T3 upon T2. 27 upon 9 is 3. Fourth term divide by third term. T4 upon T3 is 81 upon 27. That is also 3. So you can see R is equal to 3, which is the common ratio. Hence it is in GP. Okay. Second sum. These are the terms of the sequence. Let us check. 44 divided by 4 is 11. 444 divided by 44 is 111 upon 11. This is not equal to 11. It will be 10 point some decimal. Okay. So here this ratio is not equal. Hence it is not a GP. Okay. Third sum. These are the terms. Let us write down. 0.05 divided by 0.5. It will be 1 upon 10. Okay. T2 upon T1. Let us check T3 upon T2. 0.005 divided by 0.05, okay, will be 5 upon 50. That is equal to 1 upon 10. So these two ratios are equal. T2 upon T1 is equal to T3 upon T2. Hence it is a GP. Okay, next sum. 1 upon 3, 1 upon 6, 1 upon 12 dot dot. So this is the second term divided by first term. 1 upon 6 divided by 1 upon 3. So whenever you divide fraction like this, you should write 1 upon 6 multiplied by the reciprocal. Okay, 1 upon 6 multiplied by 3. So this will be 3 upon 6, that is equal to 1 upon 2. T3 upon T2, 1 upon 12 divided by 1 upon 6. So 1 upon 12 multiplied by 6. 6 upon 12 is 1 upon 2. So you can see these two ratios are equal. So this is also a GP. Fifth sum. So this is the terms. Let us find out. Minus 5 divided by 1 is minus 5. Okay, 25 divided by minus 5 is minus 5. 1 minus 125 divided by 25 also will be minus 5. So all these ratios are equal, hence it is a GP. Sixth sum, okay, 60 divided by 120 is 1 upon 2, 30 divided by 60 is 1 upon 2, but 18 divided by 30 is 3 upon 5. So these three ratios are not equal, hence it's not a GP. So seventh sum, very simple these sums are, okay, to check whether it's a GP or not. Okay, divide 4 by 16. So 4 upon 16 is 1 upon 4. Third term divided by second term is also 1 upon 4. This is 1 upon 4 divided by 1, that is also 1 upon 4. So all three are equal, hence it's a GP. Second sum, write the first three terms of the GP whose first term and the common ratio are given. So in this sum, they have given us A, that is the first term, R, which is the common ratio. They are asking us to find the first three terms. Okay, very simple. So here it is, the first term will be A and the second term will be AR. So let's write down A is equal to 6. AR is what? A into R, 6 into 3. 6 3s are 18. AR square, the third term, AR square, 6 into 3 square. 3 square is 9, 6 9s are 54. So the first three terms are 6, 18 and 54. Okay, next sum, A is equal to root 2, R is equal to root 2. So the first term is A itself. So root 2 is the first term. Second term will be AR. So root 2 into root 2 is 2. Then third term is AR square. So root 2 into root 2 whole square. Root 2 whole square is 2. 2 into root 2 is AR square. So the first three terms are root 2, 2 and 2 root 2. Okay, third sum, A is equal to 1000, R is equal to 2 upon 5. So let's write down A is equal to 1000. Then that is the first term. Second term is AR. 1000 into 2 upon 5 is 2000 upon 5, that is equal to 400. AR square is 1000 into 2 upon 5 the whole square. That means 1000 into 4 upon 25. Simplify, you will get 160. So the first three terms are 1000, 400 and 160. In a GP, find seventh term, T7. So this is the GP given to us. We have to find the seventh term. What is the general formula? Tn for nth term is equal to A into R raised to n minus 1. Okay. Now let us take the GP. First let's find out what is A. A is the first term, 729. R, the common ratio. Second term divided by first term, T2 upon T1. 243 upon 729. That is equal to 1 upon 3. So you got A, you got R. Now let us write down. We want to find T7. So put n is equal to 7 here. So T7 is equal to A into R raised to 7 minus 1. That is 6. So T7 is equal to A into R raised to 6. Okay, now you know A, 729 multiplied by R, 1 upon 3 raised to 6. Factorize 729, you will get 3 raised to 6. Divide by 3 raised to 6. It will cancel. This is equal to 1. Question 4. Find x so that x plus 6, x plus 12 and x plus 15 are consecutive terms of a geometric progression. So these are the terms of a geometric progression. This is the first term, second term, third term. That is the meaning of consecutive terms. Okay. Now we are asked to find the value of x. Okay. We know the condition that second term divided by first term is equal to third term divided by second term. Okay. That will give us the common ratio. Since it is in geometric progression, these two will be equal. Okay. So let's write down x plus 12 upon x plus 6 is equal to x plus 15 upon x plus 12. Now very simple, do cross multiplication. So x plus 12 the whole square is equal to x plus 6 into x plus 15. Now this is x square plus 2 into x into 12, that is 24x, plus 12 whole square, that is 144, is equal to, open the brackets, x into x plus 15 plus 6 into x plus 15. You will get like this. Okay, now bring all the terms to the left side. X square will cancel. 24 minus 15x minus 6x, that is 3x, plus 144 minus 90 will be 54, is equal to 0. So 3x is equal to minus 54, x is equal to minus 54 upon 3, that is equal to minus 18. Find the number of terms in the following GP. So here they have given us the GP, they are asking us to find the number of terms. Number of terms is n, okay. So we have to find out n. So let's write down. The first term a is equal to 4, r is the common ratio, 8 upon 4 is equal to 2, and the nth term, okay, is given by 8192. Okay, we do not know what term it is. We do not know the value of n. Okay, let us now substitute here. So this is the general formula. Tn is equal to a into r raised to n minus 1. So Tn here is 8192 is equal to 4 into 2 is the common ratio raised to n minus 1. We have to find out n minus 1. Okay, here simplify it further. So this will be 8192 divided by 4 is equal to 2 raised to n minus 1. So when you divide this, you get 2048 is equal to 2 raised to n minus 1. Now factorize this in a rough paper. You will find that 2 is multiplied 11 times to get this number. Okay, so 2 raised to 11 is equal to 2 raised to n minus 1. So you can see from comparison, 11 is equal to n minus 1. So n minus 1 is equal to 11. So n is equal to 11 plus 1, that is 12. So this is the answer. Second sum, this is the GP. Write down the first term a, 1 upon 3. R is 1 upon 9 divided by 1 upon 3. So 1 upon 9 multiplied by 3. 3 upon 9 is 1 upon 3. That is R. Tn nth term is 1 upon 2187. Okay. So let's substitute here in the general formula. 1 upon 2187 is equal to 1 upon 3 multiplied by 1 upon 3 raised to n minus 1. Substitute here a and r. Okay. Now if you factorize this, you will see that this is 2187 is equal to 3 raised to 7. So we can write 1 upon 3 raised to 7. This number is equal to 1 upon 3 multiplied by 1 upon 3 raised to n minus 1 is, you have to add the powers. This is raised to 1. So when you multiply it, it will become 1 upon 3 raised to n minus 1 plus 1. Because this power is 1. So minus 1 plus 1 will cancel. You are left with n. So when you compare, n is equal to 7. This is the answer. So here we come to the end of the first 5 sums of this exercise 2.7. The remaining sums I'll do in the next video. Please go through that also.